Hi and welcome to Gaffy's Grinds. This is a channel where we take concepts and experiments from Leaving Cert Chemistry. We break them down into simple, manageable chunks. We explain them and then we do some practice questions. Okay, so if you are brand new to these videos, this is going to be our first video in our playlist or our series on the organic chemistry experiments. Now, I would expect that you have done the organic chemistry theory before you start to look at the experiments, because some of the questions I ask, some of the understanding that you're going to need to know requires you to understand the theory about the experiments. So I suggest, if you haven't done so already, you need to go and watch the playlists on the organic chemistry videos before you do the experiments. Now, obviously, I will not be actually doing the experiments here. I will be describing them, I will be drawing stuff, and we will be doing some practice questions on them. So before we start the video, just eliminate all distractions that you might have. So please turn your phone off, put it in another room right now. Okay, just make sure that it's not going to distract you and overload your working memory, which is going to prevent you from learning what you need to learn here. And the other thing is, when I give you practice to do, you have to do it, guys, okay? I can't go home and try and make you do it, but if you don't, you're really not going to get that much from watching these videos. So practice is key. And when I say practice, you should be practicing from memory of what I've just explained, not looking at any notes that you have, because again, you have to try and eliminate and remove those aids. Okay, so you're trying to remember stuff. It's fine after you've tried to do it to go and check if you were right. That's fine, but don't copy, just transfer over from notes. You're not going to learn anything that way. Right, so today we're going to be looking at the production or the making of ethene and the testing of its properties. Right, so this is the first organic chemistry experiment. So we're going to start off with some quick questions to make sure that you guys understand some of the theory behind the experiment. So what I want you to do is I want you to pause the video now in a second when I ask you, and I want you to, from memory, as best as you can, try and answer these questions using full sentences in your answer. And don't play the video again until you've tried to put down an answer for these. If it's wrong, that's fine, we'll discuss it, but make sure you try your best to do the question. So pause the video now and complete the question. Okay, so you should only be watching the video again now if you have paused the video and you've tried to do them questions. Let's discuss the answers now. So the first question asked you to write the molecular formula of ethene. So the molecular formula is just a formula that describes the number and the type of atoms that are in the compound or in the formula and the number of each type. So the molecular formula for ethene, you should know that this is an alkene, and alkenes have a general formula CnH2n plus, just CnH2n like this, CnH2n. So twice the number of carbons, of hydrogens as you have carbons. That's the general formula for an alkene. Now, because it's ethene like this, ethene, that's what tells us an alkene. The other part of the name is eth, E-T-H. Now, this tells us something. This tells us that there are two carbons. So we count carbons in chemistry. 2 is eth. So this is ethene. Okay, so we've got two carbons, C2H4, because it's 2n, H2n, so 2 times the number of carbons, H4. So C2H4 is the correct molecular formula. Well done if you got that right. If not, fix it now. I'm just going to change the size of my pen here, guys, because it's just a little bit too big. So I'm actually just going to write this out again, sorry. So the correct answer here is going to be question 1. Question 1, it's going to be C2H4 is the formula, H4. Okay. Question 2 says draw the structural formula for ethene. So the structural formula basically is what we'd be familiar with. We're drawing out structures of compounds. It shows the number of each atom, the type of each atom, shows the bonds between them. Okay. So if we've got C2H4, we've got 2 central carbons like this, C and a C. And each carbon must have 4 bonds. Okay. Now, because it's an alkene, we have a functional group of a double bond between the carbons here. So there has to be a double bond between the carbons. That's 2 bonds for each carbon, and there are 4 hydrogens altogether. So if we put 2 hydrogens on each of the carbons like this, then that will satisfy each carbon. Each carbon now has 4 bonds around it, which is the key thing, because carbon is in group 4, has 4 valence electrons. It must make 4 covalent bonds. So each carbon has 4, and we're pretty happy about that. Right, question 3. To what homologous series does ethene belong? Ethene belongs to the alkenes. It's an alkene. Its name ends in E. It's got a double bond. It's an alkene, so it belongs to the alkenes. So you should have written as a full sentence, ethene belongs to the homologous series, the alkenes. Number 4. In the diagram you have drawn above of ethene, draw a circle around the functional group. Okay, so I'm going to take a different color here, and this is what you should have done. I'm going to do it in red. And the functional group of an alkene is this here, the C double bond C. So all alkenes have a carbon doubly bonded to another carbon somewhere in the molecule. That is a functional group, C double bond C. That's what you should have done. Well done if you did that. We have 2 more questions. What is a functional group is question number 5. And as you can see here, a functional group is an atom or a group of atoms that give a molecule its characteristic properties. So this is one of our definitions. It's a definition that we must learn, off by heart. And ethene is an unsaturated molecule. What does this mean? So unsaturated means that the molecule contains a double or a triple bond. So I'm not going to go into detail explaining why that is. I have done that in my other videos. So at this stage, you should know that definition. Okay, so if you want to know why that is, you need to go back and watch the theory questions again on the alkenes and what saturated and unsaturated means. Okay, now, so we've established that we are what ethene is, that it belongs to the alkenes and that it's unsaturated. Okay, well, that's what we've established so far. So let's go back now to talking about our experiment. Okay, we're going to be talking about our experiment. Now, in this experiment, we're going to be taking ethene. Okay, oh, sorry, we're going to be making ethene, producing ethene. Okay, so how are we going to do this? Well, we're going to have to react ethanol. Ethanol is an alcohol. We're going to get an ethanol. And with our ethanol, we're going to take it and we're going to convert it into ethene. Okay, now how do we do this? How does this just happen? Well, ethanol will break down into ethene, okay, in the presence of a catalyst called aluminium oxide. This is Al2O3 is the formula for aluminium oxide. Now, this is a catalyst. A catalyst is a substance that alters the rate of a reaction. So the aluminium oxide here is going to speed up the process of ethanol breaking down into ethene. Ethanol would eventually break down into ethene by itself, but it would be extremely, extremely slow. When we add the catalyst, it makes the reaction happen much quicker. So ethene plus water is another product that we're going to make here. We're going to take water and it's going to be lost off of the ethanol molecule. Okay, so that's the basics of what we're doing. We're starting with ethanol and we're turning it into ethene plus water. We'll look a little bit more detail at this later. We're going to come back to it. Okay, I'm going to come back to it and explain the formulas a little bit more. For now, we're going to take our diagram. Okay, so we're going to draw a diagram here. Okay, and in our diagram, we're going to start with a boiling tube. So this is a boiling tube. Into the boiling tube, we're going to put some ethanol because that's our starting material. This is ethanol. Now you guys should know, ethanol is written on the left-hand side of the arrow in this word equation. So in what other way can we refer to ethanol? What is it in this particular chemical reaction? It's on the left-hand side of the arrow. What does that mean? So on 3, I want you to speak your answer out loud to the screen. 1, 2, 3. Hoping that you said ethanol is the reactant. So it is a single reactant in this experiment. It's a reactant. Aluminium oxide is a catalyst. It is not a reactant. The atoms of the catalyst do not get used up or do not actually not used up, but they do not chemically combine with the ethanol. So at the end, the aluminium oxide is really just the same. The atoms are still the same. We haven't changed them. The ethanol is going to rearrange its atoms into ethene and water, but the catalyst is going to remain unchanged. So the ethanol is what we call our reactant. Now, ethanol comes with this warning symbol on the bottle. All right, so you'll have to excuse my drawing, but hopefully you get the idea. This is a picture and this is a flame. What does this particular warning mean? So on 3, speak your answer to the screen. 1, 2, 3. This warning means that it's flammable. Ethanol is flammable. That means it catches fire easily. Because of this, we're going to make sure the ethanol stays at the bottom of the tube. We don't want it. In a second, we're actually going to be setting up our test tube in this format, so on its side. So for the experiment, we need to set up the boiling tube on its side like this. And if we were to do this, obviously the ethanol is going to spill down here. We don't want that to happen. Okay, so what we're going to do to eliminate this is I'm going to put in some gray. We're going to put in what's called glass wool. Okay, we're going to put in some glass wool. Glass wool is kind of like cotton wool, but it's got little glass fibers in there. And the glass fibers stop the wool from catching fire. Sorry, I'm after writing glass fibers. That should say glass wool. So the glass wool is going to soak up the ethanol and it's going to trap the ethanol at the bottom of the container. Then we're going to put it on its side like this, and the glass wool will still be at the bottom of the tube, but it will have absorbed the ethanol and it will stop the ethanol from moving up the tube and spilling around and flowing around. We're then going to take our catalyst, which in our equation up here was aluminium oxide. Now, aluminium oxide is a white colored solid. It's a white color, aluminium oxide. Now, I can't draw it in white, so you're going to have to excuse me here. I'm going to draw it as blue. Now, it's not really blue. That's a really important point to remember. It's not really blue, but if I draw white, you won't be able to see it. So I'm drawing it as blue, but remember, it's a white solid. And you get asked about that all the time. So this is our aluminium oxide. This is our catalyst. This does not get used in the reaction. It's a catalyst. It speeds up the reaction, but at the end it is chemically unchanged. Its atoms have not been really involved in the reaction. They have not changed into something else. You could use this aluminium oxide again at the end. Underneath the aluminium oxide then, we are going to set up a heat source. Now, a heat source in this case that we're going to use a Bunsen burner. So underneath here, we're going to use a Bunsen burner. And obviously it helps if you've done this experiment for real. Well, I can't do it with you guys, but hopefully your teacher will do it with you. And then this might help you understand the theory a bit more or revise it, whatever way you're using these videos. This is a Bunsen burner and we are going to heat. We're going to heat the aluminium oxide. Okay, so we're going to heat the aluminium oxide. And when we heat the aluminium oxide and it warms up, the heat from the Bunsen burner is going to cause ethanol that's soaked up by the glass wool to evaporate, because it doesn't take that much heat to get ethanol to evaporate, because it's what we call a volatile liquid, which means it has a low boiling point. So it vaporizes even though the heat isn't directly below it. Now we do this, we heat the aluminium oxide instead of the glass wool, because the glass wool would basically evaporate much too quickly if we heat it directly. And these vapors and this liquid is flammable, so we don't really want to apply direct heat. So what's going to happen is that the ethanol is going to evaporate and pass over the catalyst. So the ethanol evaporates and passes over the catalyst. This is ethanol vapor or ethanol gas. ethanol vapor. Now, at the top of the tube is a rubber bung that we have placed. Okay, so a rubber bung. And the rubber bung has a tube which is going to travel to a water basin. And in the water basin, we're going to have a special type of a shelf called a beehive shelf. And this shelf allows us to put a test tube on top, or a boiling tube, whatever we want to use to collect, full of water. So this is a test tube or a boiling tube, test tube full of water. Now, why is the test tube full of water? Well, the test tube is full of water so that when the gas comes down, it will collect, it will bubble up, and it will collect at the top of the test tube, and it pushes the water out of the test tube. So the gas, we say it displaces water, which basically means it pushes the water out of the test tube. Gas displaces the water. We call this collecting a gas over water. Collecting over water, because you're literally collecting it on top of the water. You're collecting it over water. Now, this is possible to collect over water. It works because the gas is not soluble in water. If the gas was soluble in water, it would simply mix, it would bubble in, and it would dissolve, and it wouldn't collect at the top. So the gas is not soluble in water. This is what allows us to collect it in this way. So this is evidence that this gas that we're producing, ethene gas, is not soluble in water. We know this because we can collect it over water and it doesn't dissolve. Okay. Now, so those are the main steps. This is a water trough. Water trough. Okay, water trough. We've got a beehive shelf. On top of the beehive shelf, we've got test tubes that are full of water. And when we bubble the ethene gas up, it pushes the water out. And when it's pushed all the water out, we can put a little stopper on it, like this, like I'm doing here. Put a little rubber stopper on it, take it out, it'll be full of gas, and then put another one in on top, another full test tube in, and push all the water out of that one, and so on. And then you have 4 tubes full of this gas that we can use to test stuff. Okay, so that is basically what's happening here. That would be your diagram of your experiment. One more thing, this tube here is just a plastic tube that carries the ethene, or the product, carries it to the water basin. This is called a delivery tube because it's delivering the gas. It's delivering the gas to the water basin or to the final destination. So it's a delivery tube. Okay, I'm going to go back to the equation for a second, and we're going to draw out and look at a little bit more detail what's happening. I'm going to draw ethanol. If you've done alcohols already, if you've done the theory, you will know that the structure for ethanol looks like this. You've got 2 carbons, eth, and it's anol, which means it's an alcohol. So the name ends in ol, it's an alcohol. The functional group of an alcohol is a COH group. So an OH group. So this is the functional group here. I'm just going to highlight it. The functional group is this bit here. So if you've got an OH bonded to a hydrocarbon like this, then that means it's an alcohol. So that gives it the name anol at the end. Okay, or all at the end. Now, the other part of the name is that it's eth, which means 2 carbons, which we've done here. And it's ethane or ethanol. So it's ethane, but instead of one of the hydrogens, we've replaced it with an OH. So the rest of the hydrogens here are like this. I'm actually going to change. I'm just going to take that OH and I'm going to put it down here instead. Like this. Okay. So this is eth, 2 carbons, and all. This is our reactant. Now, our product, ethene, looks like this. We drew this earlier in the questions. 2 carbons which are doubly bonded to each other. Now, hopefully what you can see is that it's the same kind of parent molecule. It's still got 2 carbons, but we've formed this double bond in between. And now the carbons are only attached to 3 atoms altogether. Over here, the carbons are attached to 4. So if I was to just highlight for a second this carbon here, this carbon is attached to these 4 atoms. 1, 2, 3, 4. Okay. And if I was to look at this carbon, it's attached to 1, 2, 3, 4. It's attached to those 4. But these carbons, this carbon here is only attached to 1, 2, 3 atoms. Whereas this one is attached to 1, 2, 3 atoms as well. Okay, so something has changed. Some of the atoms that were over here in the reactant have not found their way to the right-hand side molecule. Okay, they have not found their way. Now, that gives me an opportunity to ask you, these 2 things up here, the ethene and the water, what way do we refer to them? The ethanol was a reactant. What do we call this? Speak your answer to the screen on 3. 1, 2, 3. Hoping that you said these are the products. So this first product, ethene, that we were looking at down here, where we're drawing the molecule, ethene, is missing some of the atoms it had in the beginning. It's missing this. If you think about it, the rest of the molecule is 2 C's with 4 H's, which is what we have in the first product. And if you look at this molecule, this is, if these were to make a molecule, this would be an O and 2 H's. That should seem pretty familiar. That is an O with 2 H's, you recognize as H2O. Okay, water. So we say that water has been removed or eliminated. So this particular type of reaction is called an elimination reaction. An elimination reaction is one in which a small molecule like this is removed from a bigger molecule. So elimination reaction is where a small molecule is removed from a bigger molecule. We'll write that out down here in case you want to take it down as a definition. Elimination reaction. Reaction in which a small molecule is removed from a bigger molecule. Now, because the molecule, sorry, if you want to write that down, you can pause it now. Write that down, what an elimination reaction is. Pause the video. Okay. Now, the particular molecule that's been removed in this reaction is a water molecule. So this is a specific type of elimination reaction. And because water has been removed, we can call it a dehydration reaction. If you remove water from your body, you get dehydrated. So dehydration reaction is an example of an elimination reaction. Example is dehydration. Sometimes the molecule being removed will not be water, so it will not be called a dehydration reaction. But a dehydration reaction is just one example of an elimination. Okay, so that's what we've been looking at today. All right, so at this stage, we're going to stop. There's quite enough. We've done quite a bit of stuff there, so we're going to stop and do some practice now. And like I always say, if you're new to these videos, it's really important that if you've written anything down there, and I really don't want you to be writing while I'm explaining, because you won't be able to listen and write and learn at the same time. What I want you to do is I want you to cover up any notes that you've just made, if you did make them, including that definition I got you to take down. And I want you to do this from memory as best as possible. Okay. So the first task I have for you is I want you to pause the video and I want you to write out this paragraph that explains the experiment. Okay. And I want you to, oh, I'm actually going to have to just teach you a few more things before we do that. Sorry. Okay. So just before we go, if we go back over here to, if you look over here at the water trough, well, that's where we're looking. All right, so what about the water trough? Well, I've told you that the gas is insoluble, is not soluble. Well, how many of these test tubes do we want to collect? We want to collect about 4 to 5 test tubes. It's important. Collect about 4 to 5 test tubes so we can do a number of different tests on the gas afterwards. We also want to eliminate. Or eliminate or discard. Discard just means to throw away. Discard the first tube. The reason why we want to discard the first tube is because when we first start heating the boiling tube over here, so you're looking over here now at the boiling tube with the Bunsen burner. When we first start to heat this tube, there's a lot of air in that tube. So before any ethene gas gets produced and flows down the delivery tube, all the air that's trapped in that tube has to travel down there first. So that means that the first tube that we collect here is going to be mostly air. It's going to be a mixture of air and some ethene, but it's going to be mostly air that's been, what we say, displaced from the reaction tube. So that one's not really going to contain much ethene. So we'll discard the first tube. What you would notice if you tested the smell of this gas that we're producing over here, the ethene, we would notice the ethene has a sweet smell. It smells quite nice, actually. It smells quite sweet. It's quite a pleasant smell. Okay. All right. So now you should be able to do this. You should be able to do this sample paragraph. What I want you to do is I want you to complete this paragraph. So write out the whole thing, not just the keywords. And I obviously want you to complete it by filling in the keywords. Okay. So pause the video and do that now. Okay. So you should only be watching the video if you pause the video and try to write out that paragraph with the keywords. Okay, so filling in the blanks. I hope that you were able to do that, and the answers are going to be coming up now. All right, so anything we missed, we'll just discuss here now for a second. I think I've explained all of this. I hope that you're understanding it pretty good so far. So here is the answers. This is what it should read as. Okay, so I'm going to let you pause the video there and make any corrections that you need to make. Okay, so you should now only be watching the video if you've paused and made any corrections. I'm just noticing that the one thing that I probably didn't explain properly here was this bit here. The appearance of the ethene, which is the product, is that it is a colorless gas. I did not explain that, and I apologize. So if you couldn't get that one, I apologize. When you collect this tube, when you collect the ethene in the tube and it pushes the water out, it might look like there's nothing in there, and that is because it is a colorless gas. But you will, if you test it, notice a sweet smell. Okay, I'm hoping that the rest of that was pretty straightforward. So I've got some questions now for you guys to practice. All right, so again, I want to pause the video when I ask, and I want you to try and do all of these questions and do them from memory. If you can, try and write the full sentence answers. It just makes your answers much higher quality. Okay, so I want you to pause the video and try to do those questions now, please. Okay, so you should be playing the video now if you have tried to do all of those questions. The answers are coming up. We're going to go through them now. Okay, so a dehydration reaction is an example of elimination reaction. What is an elimination reaction? That's the definition we talked about. It's a reaction where a small molecule is removed from a larger one. Well done if you managed to get that right. What molecule is eliminated in a dehydration reaction? Well, dehydration is to do with water, so it's going to be a water molecule is removed or eliminated in a dehydration reaction. Name the catalyst used in this reaction? That would be aluminium oxide. Describe the appearance of the catalyst. It is a white powder or a white solid. Draw a labeled diagram of the apparatus in this reaction. Well, I'm going to flip this way for that. A labeled diagram, that would be this diagram here that you need. Okay. I think you have everything you need here. Possibly add in boiling tube here. So we have a boiling tube, Bunsen burner. You want to make sure you label your catalyst. You want that labeled aluminium oxide. You want the glass wool. Now, there's probably, to clarify that, that's not perfect. We want the glass wool, and we want to label that the ethanol is soaked here. Okay, so glass wool with ethanol. That would be important to show that the ethanol is in there. So ethanol soaked up by the glass wool, we want that there. So that would be a scoring point, if you like. Aluminium oxide would be a scoring point. Boiling tube, the Bunsen burner, the delivery tube should be labeled, the water trough, the beehive shelf, the test tube, and the gas up here displacing the water. So all of that would be required in that to be a good diagram. So well done if you managed to do that. It's quite a lot of detail there. If you didn't, you should pause the video and add any detail there that you missed. So do that now. Okay. So again, you should be watching the video if you have made any corrections necessary there. Next one says, in this experiment, ethanol dehydrates to produce ethene and water. Write a word equation for the reaction in this experiment. Okay, so a word equation uses words to describe what's happening. So this is number 6. So number 6. Okay, screen's frozen on me here. Give me a second. Come on. There we go. Okay, number 6. We have ethanol. Ooh, too big. Ethanol. We don't say plus. If you wrote plus aluminium oxide like this would be wrong. This would be incorrect, because that would suggest that the aluminium is a reactant and its atoms mix with ethanols to make the product, and that's not true. As you see in a second, there is none of the product that has any aluminium atoms in them. Okay, so ethanol, we show a catalyst up here then, aluminium oxide. We show a catalyst, we write it on the arrow. To produce ethene plus water. That would be a correct word equation for this experiment using words. Ethanol reacts to give you ethene plus water. As you see, ethene and water, neither of them have any aluminium atoms. So that's why aluminium is not a reactant. Because if it was, we would expect to see some of those aluminium atoms in the products, and we don't. Question 7 asked for a balanced symbol equation for this reaction. Well, I'm hoping you knew the equation for ethanol. If you didn't, I'm going to tell you now. And then, so ethanol equation or formula looks like this. C2H5OH. Arrow, the catalyst is Al2O3. So if you didn't know the equation or the symbol equation for ethanol, I want you to pause the video again now and try and write out the rest of that equation. Okay, so you should now have C2H5OH reacts to give C2H4 plus H2O. Now we need to check if it's balanced. Remember, we have to obey the law of conservation of mass. What is the law of conservation of mass? Say out your answer now. 1, 2, 3. I'm hoping that you said the law of conservation of mass states that atoms cannot be created or destroyed. So we must not create or destroy any atoms here. We must have the same before and after the reaction happens. Well, I'm seeing 2 carbons here, C2, and I'm seeing 2 carbons here. That's good. They're balanced. I'm seeing 5 carbons here and another one here. That's 6. I'm seeing 4 and 2 is 6. That's good. And I'm seeing a single oxygen atom here, and I'm seeing a single oxygen atom here. So in fact, that's actually already balanced for us. So C2H5OH gives you C2H4 plus H2O. Well done if you got that right. Number 8 asks, explain why the first tube collected is discarded. First tube collected is discarded because it contains mostly displaced air. Number 9, when you stop heating, it is very important to remove the delivery tube from the water trough. Explain why. Damn, I forgot to explain this. I've missed out a few things here. I need to prepare this better. I apologize. Right, now, I'll take an opportunity to explain it now then. Okay, so we've got our boiling tube, and when we are heating, we've got a flame here. When we are heating, what's happening is all the gas particles inside the tube here, we are increasing the pressure, which means they start to move more quickly in all directions. So the pressure in here, we say, increases. And when it increases, there's an escape route, and that's down the tube. So they will start to move down the tube. So heating increases the pressure. Okay, increases the pressure, pushes gas particles out of the container. When we remember, then this tube is going down and it's in water, which is cold. This is cold water. When we stop heating, when we eliminate the heat, what starts to happen is the tube starts to cool down. The tube starts to cool down, and when the tube starts to cool down, that pressure inside starts to decrease. So the particles start to slow down, decrease in pressure. Okay, and what that decrease in pressure does is it makes more space in the tube. More space in the tube. Because the particles aren't as expanded anymore. They're not moving about as much. So they start to stop moving as quickly, and they start to come closer back together again. They start to form, come closer together. And what that does is it starts to suck water up the tube. Water gets sucked up. And we call this suck back. Now this can be dangerous when the water is really cold, because when the water is cold and it gets sucked back up, the cold water can actually end up, so if the water's down here, it can actually end up traveling up into the tube, and the cold water can crack your test tube. Smash it, because basically the glass gets shocked. It goes from being really hot, from being heated, to cold water getting sucked in and causing it to crack and break. Okay, you got broken glass everywhere, can break into small pieces, so it's a safety hazard. So why do we want to remove the tube? The way we can stop it is as soon as we stop heating, is if we take the tube out of the water, so remove the tube from the water, then it won't be able to suck any of the water up. It'll suck back, but it'll be sucking back air. And the air isn't a big issue. You can suck air into the tube, no problem, from the room. It's not going to cause the test tube to crack. So we want to prevent that thing called suck back. That's why we want to remove the tube. You could also disconnect it up here. So if you didn't want to remove the tube from the water, you could disconnect it here, which means you could disconnect the rubber stopper. That would be another way of doing it. If you pulled out the stopper, then it's not going to suck back the water from the trap. It'll just take air in from the room. But because the tube is quite hot, we don't really want to necessarily go touching the stopper, because it could burn it. So it's easier to remove the tube from the other end, from the trough, and then it won't suck water back. So we're trying to prevent that thing called suck back. Okay, so I'm apologize again. I did not explain that properly when I was going through the explanation. So that was question 9. When you stop heating, it is very important to remove the delivery tube from the water trough. Explain why. Okay, so the delivery tube must be removed, that should say, removed from the water. Sorry, I'm going to fix that now. Must be removed from the water trough to prevent suck back, because suck back will crack your test tubes. Number 10, explain why it is important to keep the flame of the Bunsen away from the gas product. Well, the gas product ethene is flammable, so we want to keep the flame away so that it doesn't catch fire. A student says ethene is soluble in water. Using this experiment, explain why the student is wrong. Well, the student said ethene is insoluble in water. Well, hopefully you recognize that the student is wrong because ethene is collected over water in this experiment. This would not be possible if the ethene was soluble, as it would just mix with the water. So it would not be able to be collected separately. It would actually just dissolve in the water. So that proves that the student is wrong. Now, okay, so once you have actually collected your 4 to 5 test tubes of your gas, you've done everything safely, you've tried to prevent suckback, you have tried to avoid setting the ethene on fire with the Bunsen, well, now it's time to actually do some tests to test the chemical properties of ethene. So the first test that you can do on ethene is to test that it is a fuel, because when we learned about ethene, or the alkenes, we learned about them as fuels. So a fuel is a substance which can burn in oxygen to release energy. And it does this through a process called combustion. Now, we've just collected 4 test tubes of a gas, but we can't be sure what the gas is. So one of the tests we can do to see if it's a fuel, we can do what's called a combustion test. Combustion test. Okay, so in a combustion test, we take our test tube that we've collected. Okay, and our test tube is full of ethene molecules. Now, you can't actually see them because it's a colorless gas, but I'm just drawing them here. Just make sure you understand that they are in here. We've got ethene gas. Okay, and it would obviously be stoppered until you're ready to do the test on it. So when you're ready to do the test on it, what we would do is we would light a wooden splint, which is just like a stick that we use in chemistry. We would take a splint, a wooden splint. We would ignite it, set it on fire like this. So this is fire. And we would then remove the stopper and expose the wooden splint with the flame to the ethene. Okay, so in a combustion test for ethene, what we would see is a flame. And it would be quite a bright flame. So I'm going to draw in like an orange color. It's quite a bright, luminous flame is what we call it. All right, so a luminous flame. Come on. Okay, so I'm going to just make that bigger. Okay, it burns with a luminous flame. Okay, now, so after it burns then, all the ethene gas molecules burn. And what this would look like is the flame would move down the test tube until all the gas, all the way down to the bottom, has combusted. So combustion, that word just basically means burning. Combustion means burning. So we're burning the gas, we're testing to see if it burns. That's a combustion test. Now, this is a fuel. Whenever we burn a fuel, we always produce 2 products. Now, we require a specific gas for combustion, and that is oxygen. So a fuel plus oxygen always gives us the same products. It gives us carbon dioxide plus water, always, when we burn a fuel. Now, ethene is an example of a fuel. This is something that you're going to have to really remember. A fuel plus oxygen always reacts to give carbon dioxide and water. Now, because carbon dioxide is one of the products, this is a product, we can test our product after we combust the ethene to see and to check that it's carbon dioxide. So after we've burned, we will then have a test tube which still looks empty. We've got what looks like an empty test tube. And what we're going to do is we're going to take a reagent. Okay, we're going to take a reagent. We've got a reagent in a beaker here. This is a reagent that we call lime water. And lime water is colorless. Colorless liquid. We're going to take our lime water and we're going to put it into our tube where we've just done our combustion. Okay, no, we don't need that, sorry. So we put our lime water into our tube. So we have our lime water in our tube. It was colorless, but when it mixes with carbon dioxide, it forms, so we've got lime water. And lime water has this formula, CaOH2, calcium hydroxide. Okay, CaOH2 plus CO2, that's what we're doing. Lime water plus carbon dioxide. When we mix these two things together, we get a substance called calcium. Sorry, not there. We get a substance that we call calcium carbonate. Which is essentially limestone, CaCO3, calcium carbonate. And this substance is insoluble. It doesn't dissolve. And because it's insoluble, it's a white color. It forms a white precipitate. So a precipitate is where a solid forms that doesn't dissolve in the water. So one of the products here is a solid white substance that doesn't dissolve in the water. The other product that we make is water, H2O. So that is an equation here for the reaction between lime water and carbon dioxide. That is the equation for it. And it's balanced already for us. Okay, now, because this substance is insoluble and forms a white precipitate, we see this over here, a white precipitate gets formed. If carbon dioxide is there, then this happens. If carbon dioxide is not there, then calcium hydroxide, the CaOH2, just stays the same, and it doesn't form a white precipitate. So if this is there, then you get the white precipitate formed. And if it's not there, you will not get a white precipitate formed. So that is the test for carbon dioxide. So we do this after we have done a combustion test. We test that the product that has been made is carbon dioxide. Another test that we do on our sample of ethene is we take, we're going to do a test for unsaturation. Unsaturation. Remember, unsaturation means it's got a double or a triple bond. So it's got a double or triple bond. We have to see if we can prove that or if we can test for it. So what we're going to do is, there's actually two ways of doing this, two tests. We take our test tube that contains a little bit of, that contains our ethene gas. Again, so we've got our second, this might be the third or fourth test tube we collected. We've done the combustion test on the first one. We've got another test tube that's got ethene gas. Ethene. And to this, we're going to add another reagent. We've got a beaker of another reagent, and this reagent is called bromine water. Bromine water. Now, bromine water is a brownish kind of orange substance. So it's orange in color. Orange. And we're going to take, so we're going to put this here. We're going to take our orange solution and we're going to put it into the ethene, give it a quick shake. So we'll put a few drops of the bromine into the ethene and we give it a quick shake. Now, to explain what happens here, we have to look at the ethene. Remember, our structure of ethene looks like this. Carbon double bonded to another carbon with 4 hydrogens around it. When we add bromine water, which is essentially Br2, bromine. It's diluted bromine, so it's Br2. We get this reaction happening. Jeez, this is really annoying. Sorry, I don't know what's going on with this now. Not doing what I wanted to do. Pause it for a second, I'll be back. Okay, so when we mix the bromine water with the ethene, what we get is this product. So basically, the bromine breaks the double bond and sticks one, remember bromine is Br. One of the bromines sticks, so basically one of the bromines sticks on to each of the carbons here. We're going to get one attaching to that carbon and one attaching to that carbon, and the double bond gets broken. So what we end up with is this guy. We end up with carbon with the double bond is now broken, so it's got single bonds. The two Brs are stuck on like this, and we now have the rest of the molecule there. Now, if you've revised fully or you've done all of organic so far, you will recognize that as a specific type of reaction called ionic addition, which I'm not going to go into too much here. I'm not going to spend too much time doing, but this is an ionic addition. And this substance happens to be colorless. So remember, the bromine water was orange in color. Bromine water was orange or brown. And this substance is colorless. This substance is colorless. So that's why when we add the bromine water, which was orange, so this was an orange colored liquid, we mix it. If ethene is present, that means this reaction will happen and you will get a colorless product formed. So we say that the test here goes from colorless, or we say bromine water, sorry, I should write the whole lot. Bromine water turns from orange to colorless if it comes into contact with an unsaturated compound. So that means we can use the bromine water to test for unsaturation, because if it comes into contact with an unsaturated molecule, it will turn from orange to colorless. That is the first test for unsaturation. There is another way of doing this. It's a similar kind of idea. And that is that we take our test tube of ethene gas, so this might be test tube number 5, and we take a different reagent. Instead of bromine water, we're going to take a purple colored liquid, and this is called acidified, because it's got acid in it, acidified potassium permanganate. We'll take our acidified potassium permanganate, that's purple, and when it comes into contact with an unsaturated compound, the manganese in this potassium permanganate turns from a purple color to a colorless substance. Okay, so we don't really need to know the reaction there. Okay, so I'm not going to go into that one, explain in detail. But the test for unsaturation, where we use acidified potassium permanganate, is acidified potassium permanganate. Potassium permanganate goes from purple to colorless. Again, this only happens when it reacts with an unsaturated compound. If it reacts with any other compound that's not unsaturated, this color change won't happen. It will stay purple. So that's why it's a useful substance to use if we want to test to see if there's an unsaturated compound present. If we put in the potassium permanganate, then it will change from purple to colorless. All right, time to do some questions now, okay, on those tests. So do some questions on them tests. Here they are. So questions 1 to 10. I want you to do those questions now, please. Okay, so pause the video and complete them questions like you did before. All right, these questions are coming up. I'm hoping that you were able to do all of them. And what you guys are going to do now is you are going to do the corrections. Okay, so what is combustion? Combustion is burning. What gas is required for combustion? Oxygen is a gas required for combustion. Number 3 says, what is observed when ethene is combusted? You see a luminous flame, which means a bright flame. The products of any fuel combustion are always carbon dioxide and water vapor. Write a word equation for this reaction. All right, so let's do that here. We've got, of course, that should be number 5. Sorry, I'll fix that in a second. The products of any fuel combustion are always carbon dioxide and water vapor. Write a word equation for the reaction. Right. So we have ethene, which is a fuel. We've got ethene plus oxygen gives you, and we know the products of any combustion are always carbon dioxide plus water. Okay, so the next question asked you to write a balanced symbol equation for the reaction. So a balanced symbol equation. So again, I see my numbers are a little bit messed up here. This should be number 5. That should be number 5. That means that should be number 6 and so on. I don't know why they won't fix themselves. There we go. Okay, so number 5, write a balanced symbol equation. Okay, so the symbol equation or the symbol formula for ethene is C2H4. The symbol equation for oxygen, you should know by now, is O2. Carbon dioxide is CO2, and water is H2O. Well done if you did that much. We need to check now if it's balanced. So if you weren't able to do the first bit by writing out the symbols, pause now and check that it's balanced. Okay, so you're only watching the video if you've got a balanced equation in front of you. Okay, so let's check that we have obeyed the conservation of mass. Well, here on my right-hand side, I'm seeing 2 carbons, okay? And on the right-hand side, I'm only seeing 1 in the carbon dioxide. So that's the first thing I'm going to do is make that a 2. So I've got 2 carbons now on each side. Counting my hydrogens, on my right-hand side in my products, I only see 2 carbons here, and I have 4 here. So I'll fix that by putting a 2 in front of the H2O. Now I've got 4 carbons. 2 times 2 hydrogens is 4. And the oxygens, I've got 2 oxygens here, and now I've got 2 times 1 oxygen, which is an unwritten one there. As my class anyway, they definitely know that that's an unwritten one. That means there's 2 oxygens, so that is balanced. Okay, so that is now our balanced equation for the combustion of ethene. Okay, so well done if you managed to get that right, guys. Number 6 said the presence of carbon dioxide can be tested for using a reagent. Name this reagent. That would be lime water. The reagent used to test for carbon dioxide is lime water. What is observed during this test? When lime water reacts with carbon dioxide, a white precipitate is formed, turning the lime water a white or a milky color. So a white precipitate is seen, and that makes the lime water be a milky or a light white color. Number 8, ethene is unsaturated. Explain the underlying term. So unsaturated means the molecule contains a double or triple covalent bond. That's what unsaturated means. Name 2 reagents that can be used to test for unsaturation. Bromine water and acidified potassium permanganate are the 2 reagents. And for each of the reagents above, describe a result that will show that ethene is unsaturated. Well, bromine water turns from orange-red to colorless. and acidified potassium permanganate turns from purple to colorless. All right, guys, well done. If you got all those correct, I hope now that you understand that experiment much better. And we've kind of covered everything that you could really be asked on that. So I'll see you in the next video where we'll be discussing the production of ethane gas. All right, so I'll see you in the next